Hello everyone. In this video, we are going to continue with what we were doing before. Continue with what I did in the last video, which was introduce the idea of inventory simulation to you. And we will continue with, in this, I'll go over the Excel formulation of that inventory example. So we saw that we are selling routers. The demand for routers was the mean and standard deviation of demand for routers was 120. We are assuming that it follows a normal distribution, which is actually a very commonly made assumption. Demand following a normal distribution is a very, very common assumption. Right. On top of that, we say that we have a replenishment level Q. Now we are going to look at different levels of replenishment. So we'll either have a replenishment level of 100, 110, 120, 130, or 140. What this means is that at the end of each month, our inventory will be bought back to the same number. So whatever inventory we had before, we could have had zero inventory because we sold every router we had. But at the beginning of each month, we'll have 100. If we sold only 10 routers, we will only order 10 of them to bring the inventory back to 100. But if we sold all 100, we will again order 100 units, so bring it back to 100. So the idea is that we'll have a fixed replenishment level, and every time at the beginning of the month, we'll have the exact same number of routers on our hand. And so the idea is to see which of these replenishment levels make sense and look at the ideas of service level and the average net profit, right? So that's what you're going to do. So to do that, I set up this Excel file with all the data that we have so far. So we need to keep track of which month. We want to simulate this for 1000 months. So we will do a 1000-month simulation. And also demand is the only point of uncertainty here. Everything else is known. So we know the mean and standard deviation for demand. It's a point of uncertainty. So we assume it's a random variable and associated with a probability distribution, in this case normal. The sales price is 125, cost is 75, so the gross profit per unit is $50. Now holding cost is $15 per unit and shortage cost is 30. So if your demand is more than what you hold on hand, you'll have to pay a shortage cost, and that is $30, right? So right now the replenishment level is 100, and what we'll do is we'll do this for multiple replenishment levels and then compare all the results together. Right? Okay, so let's do this. So let's do month number 1 first, and we'll take it from there. So let's generate a random number. Now, you don't have to generate the random number separately. When we write the demand formula, the random number formula can be part of the demand formula itself, right? But I like to generate my random number separately, right? So now we write the demand formula. So it's the inverse of the normal distribution. So why is it the inverse of the normal distribution? Well, we'll see that in a second. So when you do normal inverse, you need a probability number, and that's that probability number. Now, mean and standard deviation, we know mean is 100. I'll make that an absolute reference because 100 is always going to be there, and standard deviation is 20. Again, I'm going to make that an absolute reference, right? Now, you'll notice that the probability, the first number doesn't have, the probability number doesn't have an absolute reference because we're going to generate different random numbers and use different values, but the mean and standard deviation remain the same. Now, this is the inverse of the normal distribution because this is the way we generate these random numbers is, if you remember the bell curve that you have, the normal distribution bell curve, the total area under the bell curve is exactly equal to 1. And the reason for that is sum of all possible probabilities has to add up to 1. Now, if you take any other value on the x-axis and draw a vertical line till it touches the normal distribution curve and find the area to the left, that is the probability of being less than or equal to that number. And that probability is going to be a number less than 1. And when we generate a random number, we are going to represent that area or that probability as using that random number. So that's the randomness that we are looking at. Right. So because we are using probability to find the value on the x-axis rather than the other way around, we are using the inverse formula, right? There you go. So that's my demand, but the problem is we are selling routers, so we do not want a demand to be a fractional value. So I am going to round it. I'm going to round it to 0 decimal places. And there you go. All right. Now, once I have demand, I also need to do sales. So when I'm looking at sales, so sales are based off of the replenishment level, right? So if my demand is 100 and my replenishment level is 100, I've sold exactly all, I've sold every one of my routers, right? So I'll have 100 in sales, I'll have no holding cost, I'll have no shortage cost, and my gross profit will essentially be the same as my net profit, right? So my sales will be, so what will my sales be? So if my demand is less than the replenishment level, so if my replenishment level is 100 and my demand is 90, I will only sell 90 routers. But if the replenishment level is 100 and demand is 110, I will only sell 100 routers because that's how many routers I have on hand. So sales will be the minimum of either the demand value or the replenishment level. Now the replenishment level is going to be the same, so I'm going to make that an absolute reference. Again, you could have just typed in 100 here and that will work too. But I want to change my replenishment level and change the formulas automatically. So I'm doing that, but you don't have to. So what this does is when I generate a different number, so when demand is 87, my sales are 87. But if I generate a different random number, right? Demand is 118, then sales are still only 100 because I only have 100 routers on hand. But for the 18 extra routers that I have, I will be assessed a shortage cost. And that's the idea there. Now, gross profit. So gross profit will be based off of the sales. So gross profit per unit is $50. I'm going to make that an absolute reference. Oops, sorry. Times. So $50 times the sales, whatever my sales are. And sales are not going to be an absolute reference because sales will change with every month. So that's my gross profit. My holding cost will be, I will be assessed a holding cost if my sales are if my demand is less than sales. Say for example, let me get a scenario. Oops, sorry. In this scenario, demand is 86, right? Sales is also 86. Now I will have a holding cost because my demand is less than my replenishment level. So it comes down to that case. We have to look at the replenishment level, and whichever is smaller, that's the one that we're going to use, right? So my holding cost will be, right, my replenishment level minus demand, right? Replenishment level minus demand times, so this is how many units I have left over. So replenishment level is 100, which means that I have 100 routers in inventory. My demand is 86. Actually, let's use sales here. My sales is 86, right? So I'm only selling 86 units. So replenishment level minus my sales times the holding cost. So holding cost per unit is $15. I'm going to make that an absolute reference. And my replenishment level also has to be an absolute reference, right? Okay. Oops. Nope. This is my replenishment level right there. Being an absolute reference, right? So replenishment level minus sales times the cost of holding. That's my holding cost, right? Now let's look at the shortage cost. So shortage cost will be, so we have a shortage if demand is more than the replenishment level, right? So I can say demand minus replenishment level, right? Hang on. That's fine. So demand minus replenishment level times the cost of shortage. Now the important thing to keep in mind here is that, okay, the cost of shortage is also absolute reference. Replenishment level is also an absolute reference, right? Okay. Now, the only thing to keep in mind is that you cannot have a negative cost. You either have a cost or you don't have a cost. Now, we will never have that problem with the holding cost because when you wrote the formula for the holding cost, we use sales, and sales already includes the fact that if demand is more than 100, you're already just making a sales of 100. So if you sell 100 units, the replenishment level is 100 units, you don't have any holding cost. So holding cost is easy, but with the shortage cost, we have to keep track of that. So shortage cost is, you're taking the difference between demand and the replenishment level, but only if demand is more than the replenishment level. If demand is not more than the replenishment level, well, then there is no shortage cost. So the other way to think about that is, if this number is negative, then it doesn't make sense, right? So this number cannot be negative, or in other words, demand cannot, if demand is less than the replenishment level, the shortage cost is 0. So we will write this as a function where we'll say that this is the the maximum of 0 and this number. So by writing this formula, so before I wrote the maximum formula, the inside formula was just the difference between demand and replenishment level. Now what we are saying is that if demand is less than replenishment level, then the difference between demand and replenishment level will be negative. So if it is negative, then my shortage cost would be 0. So I want to pick the larger number between 0 and the shortage, the cost I have. If the shortage cost itself is positive, then we have a shortage cost. Then in that case, it's more than 0, that number gets picked. But if shortage cost is negative, then the number that gets picked between 0 and a negative number will be 0, because we are doing a maximum function. So you're saying maximum between 0 and this number, right? And there you go. Now, one thing I want you to notice is that you'll either have holding cost or you'll have shortage cost. You cannot have both, right? It's either one or the other. So if I press F9, you'll notice this, right? So in this case, because demand is 104, I have no holding cost. I have replenishment level is 100, my sales are 100, I'm selling everything. But I have a shortage cost of 120 because I have 4 extra units, 4 people who wanted the routers and didn't have routers, and I'm paying $30 in shortage cost for each of those people. And that's the idea. And the net profit will be gross profit minus the holding cost minus the shortage cost. That'll be my net profit. And there you go. All right. So this is one single scenario. So as I press F9, I want you to notice that if demand is more than sales, like you have here, you have a shortage. But if demand is less than sales, like you have here, you have holding and no shortage. That's the juggle that happens. All right. So all right, so that's my net profit. So this was a simulation for 1 month, and we want to simulate this for 1,000 months, and then we also want to average those numbers. Right? We want to calculate some average metrics. So the metrics that we actually want to calculate are the average profit and the service level. Right, average profit and service level. So let's first run this simulation for 1,000 units. Okay, that's good. It needs to go down for 1,000. I know there's a much better way of doing this, but I just like seeing the numbers increase this way. All right, 1,000 right there. Right, so I did 1,000 simulations here. Okay. Now let's kind of find the average profit. This part is easy. The average profit is, I'm going to do something that I did not do in class, but I did that in the video that I've posted. So I posted a video on Canvas that also goes over the same what if analysis that I did in class in a slightly different way, not very different at all, just different in the way that I set up the Excel sheet, but otherwise it's exactly the same. And one thing I did there is that to make my life easier, I hid a lot of these rows. So I'm going to do that. Okay, I'm going to show maybe the last. Yeah, let's do that. So I just choose a bunch of these rows and then I just hide them. So you'll notice that the number jumps from 16 to 993. It's just that the rows are not, it's not that the rows are not there. It just makes it easy for me to write the formulas and such. So average profit. So when I write average profit, I say average of all the numbers from here all the way to the end. So this includes all the numbers in between, even the 16 and 990. So it'll pick every one of those numbers and we got the average one. Now, so average profit is good. Now let's look at the service level. So what exactly is the service level? Service level tells you how often you were able to satisfy demand. That is, how often did you not have a shortage? So if you have a shortage, then, well, if you had a shortage, then it means that you were not able to satisfy demand, right? So, yeah. Okay, I'm sorry. That is actually the what I defined before as the service level is actually the fill rate. We're not looking at the fill rate here. So service level is the percentage of total demand that is actually satisfied, right? So what percent of the total demand actually got satisfied, that is the service level. So what exactly does that mean? So how would I calculate that? So we can get that from the demand and sales value. So I know my total demand. So if I add up all the demand values, that will be the total demand that I saw in over the 1,000 months. Of all of those demand, how many units did I end up selling? Well, that's equal to the total sales. So if you look at the total sales as a percentage of total demand, that is the one that gives you the service level. And let's calculate that. So to do this, I'm just going to add up, sum all the sales. So total sales, that's my total sales. And this I'm going to divide by total demand. Total demand right there. There you go. So that's my service level. So I'm going to make that a percentage. Show a couple of decimal places. There you go. So 91.69, and this will change obviously as we change the random numbers, but it won't change by that much, I think. Yeah, it's staying around 91, 92%. So that's the service level that we have. Even the average profit, you'll notice, is 4,200 something. It's not changing outside of 4,200. Sometimes it becomes 4,190, but never more than that, right? And that's the idea. So that's my average profit and service level if my replenishment level was 100. So I'm going to say this is the example when Q is 100. Now, what I want to do is let's do the same thing for Q is 100, 110. We'll do the 5 different. So move a copy, create a copy. So this is the 110 case. So what if my replenishment level is 110? So all I have to do is, because I wrote the formulas and everything based off of this number right here, I'm just going to make it 110. There you go. So you'll notice that service level increased significantly. Again, if I keep pressing F9, oops, not F10, F9, you'll notice that service level stays around that 96% mark, right? Slightly less, slightly more, but around 96%. The same goes here. So I'm going to make another copy. So we'll do everything up to 150, right? Oops. Let's do 120. Yeah. Then we'll do 130, 140. There is a better way to do this also, but you know what? I don't feel like going through that. Let me quickly make copies and then we'll go and change them. 40, right? So going back here, we did up to 140. Yep. So those are the ones that we did. So let's go. So to 120, you'll notice that service level jumped to around 98.36%. If you do 130, it'll jump up to 99 point something. 140 will be even more. All right. Now, so what I want to do now is I'm going to create another page. I'm calling this aggregated. Aggregated results. Right. So what we'll do here is we'll create a table, exactly the one that they created. So let's create the replenishment level. Right. So we have replenishment level. The other one was average profit and service level. Okay. Now, all right. So replenishment level, average profit, and average service level. Right. Now, if you notice, it says Q is 100, right? So I just want to copy this down here. It's all in the same place, right? So just trying to be slightly better than this. I'm just gonna 110, 120, 130, 140, right? Now, this will be 110. It's going to be 120. 130. Finally 140. All right, so there you go. So these are my replenishment levels. So these are all my average profit values. Right, and I want you to notice, so profit goes up, then profit goes down, and profit goes down. Even though the service level is definitely increasing because you're able to satisfy more of the demand, still it doesn't make sense for you to have either 130 or 140 as a replenishment level. Between these five values, 120 is the one that makes the most sense, because that is the one that gives you a higher profit and also gives you a decent service level, right? 98.07, that's a very good service level. You're only not satisfying 2% of demand. All right, that's it, and that's the idea here. So so that is a simulation of inventory. So if you know what the news vendor model is, and if you know seasonal inventory management or whatever, so if you understand those ideas, this is exactly that. So we have simulated the news vendor model essentially, right? And these are the different order quantities that you have in the news vendor model. But if you don't know the news vendor model, don't worry about it. We have done an inventory simulation, looked at the different replenishment levels, and then done something around it. All right. Okay, the video is already too long, so I'm going to stop it here. And yeah, I will hopefully this video goes up on Monday, and I will see you all next week. Have a great Thanksgiving. All right.